yesterday we integrated and we talked about that integration symbol. But for the most part yesterday, we didn't have any numbers on top or on bottom of that integral. Now, in the Riemann sums, we did a little bit and that would talk about the time period that we were considering here. Today we're going to focus in on having those numbers on top and bottom of those integrals. This makes it a definite integral. When there are no numbers on top or bottom of that little S symbol, it's an indefinite integral. But when there are numbers, it is a definite integral. So if f is continuous and non-negative on a closed interval, then the area of the region bounded by the graph of f, the x-axis, and the vertical lines x equal a and x equal b is given by the integral from a to b of f of x dx. And that's kind of what we were doing with the Riemann sum, is that when it said explain the meaning of this integral from 0 to 90 on the fuel problem, it was the total number of gallons of fuel that were consumed between 0 and 90. On number 1, set up a definite integral that yields the area of the region. So the area of this shaded region would be the integral of the equation, which is 4 minus x squared dx, because a dx always goes with the integral. And then I would want to integrate from x value, lower x value to upper x value. So between what two x values? -2 and +2. The dx means that the 4 minus x squared is a derivative. And in order to solve this, you need to integrate it or find the function whose derivative is 4 minus x squared. And then in just a minute, I'm going to show you how to actually solve this. All right, there are a couple of special properties. If f is defined at x equal a, then the integral from a to a of f of x would equal what? 0. Good. Why? If you just integrate from, say, x equal 1 to 1, then you're just finding the area under that curve between x equals 1 and x equals 1. There's no width to that rectangle. So good, the area would be 0. Okay, if f is integrable on a to b, then the integral from, does that say b to a? Yeah. Okay. Oh, you read it bottom to top. So does this say b to a? Yeah. Bottom to top. Okay. What that does is it equals the negative of the integral from a to b of f of x dx. That's just a property. There's a proof of it in your book. Okay, if f is integrable, that just means you're able to integrate it. And non-negative on ab, what does that mean? All of the y values are positive, right? So the graph is above the x-axis. It does. So f is all above the x-axis, then the integral from a to b of f of x dx will always be greater than 0. Okay. All right, so this brings up the fundamental theorem of calculus. Do you think this is important? Yes. Yes. Okay, if they're willing to call something the fundamental theorem of calculus, it is definitely important. All right, so f is continuous between a and b. Big F is the antiderivative. So if big F is the antiderivative, little f is the derivative of big F between a and b. Then the integral from a to b of f of x dx equals big F of b minus big F of a. Okay? Let me just work the problem to show you how this works. So evaluate the definite integral in example 1. So the definite integral in example 1 was the integral from -2 to 2 of 4 minus x squared dx. Okay, so if I'm integrating little f, I'm supposed to get big F. So basically, I need to integrate first the 4 minus x squared. Well, what's the integral of 4 minus x squared? 4x minus 1/3 x cubed. Okay. Okay, plus c. Thank you. Now, the way that the notation works here is that you integrate, and then on the right side, you draw a vertical bar and say, I'm going to evaluate this from -2 to +2. And notice that in the formula here, the bottom number is A and the top number is B. So they take the integrated formula, big F, and then they're going to plug in a B minus, and then plug in an A. So you do the top minus the bottom. So if I plug in the top one, I'm going to, 4 times 2 is 8 minus 8/3 plus C. So I plugged in the 2. So this was basically F of 2. And then I'm going to plug in the negative 2. And if I'm subtracting the whole quantity F of negative 2, I need some parentheses here. So plugging in a negative 2, I'm going to get negative 8 plus 8/3 plus C. Everybody okay? Okay, so let's clean this up. Or at least distribute. So I've got 8 minus 8/3 plus C plus 8 minus 8/3 and then minus C. What happens to those C's? They cancel. Do you think they're always going to cancel in every single problem like this? Yeah, because you're subtracting that second one. You're taking the first thing, which is always going to have a plus C in it, minus plugging that same thing, but plugging in a different number that's always going to have a plus C. So for a definite integral, you actually do not have to put the plus C in there and worry about it, because they will always, always, always cancel out. And here's some more good news. I am perfectly okay with you writing this as 16 minus 16/3 and being done with it. The line with the negative 2 and the 2 is just the notation that you use. So at this point right here, it's telling the people that are reading your work that you've integrated and you're about to plug in a 2 and then minus plug in a negative 2. It's just the proper notation. All right, so if you want to integrate, all of your calculus features are under F3, just like the derivative was. So under F3, what do you think we're going to choose? Number 2. Okay, and it puts that little squiggly S symbol in there. All right, let's first just integrate the 4 minus x squared. So 4 minus x squared. What do you think I need to do before I close my parentheses? Comma x. Very good. Okay. All right, so I'm asking the calculator to integrate 4 minus x squared, 4x minus 1/3 x cubed. The only thing the calculator does not do is put in the plus c. It makes you remember that. All right, but let's say we wanted, so that's the indefinite integral. Let's say we want to do the definite integral. Go back to after the comma x, but before you close the parentheses. So we're going to do comma x, then we're going to do comma negative 2, comma positive 2. So that means we're going to integrate that with respect to x between negative 2 and positive 2. Yeah, you always put the one that's listed on the bottom first. All right, and then notice that when it comes up on the screen, it puts that negative 2 and positive 2 on top and bottom of that little integral symbol. And if we had found a common denominator and simplified our answer, we would have gotten 32/3. Yes? All right, so evaluate this right here. So the first thing you do is you integrate. So what is the integral of negative 3x plus 4? Plus 4x. Good. Okay, and then if we, so on last night's homework, we just would have said plus c and been done with it. But because we have the definite integral, then that means that we have to evaluate it between 2 and 5. So the way that we tell whoever's reading our paper is that we put that vertical bar and the lower limit on bottom and the upper limit on top. And then we plug the top one in first. So negative 3/2 times 25 plus 20 minus, and plug in the bottom number, the 2. So negative 3 halves times 4 plus 8. I would like for you to clean it up some here. I mean, I want you to get to the point where it's either a number or a whole number plus a fraction. So this is negative 75 halves plus 20 plus 12 halves is 6 minus 8. And 26 minus 8 is 18, so negative 75 halves plus 18. Now, if you want to take that a step further and write 18 as 36 halves and add those together, that's fine, but I'd like for you to at least get to the point of negative 75 halves plus 18. Okay. Easy enough? Yeah, okay, that's the basics of this. All right, 4, find the area of the region that's bounded by this graph, the x-axis, and the lines x equals 0 and x equals 2. So we would be talking about that region in there. Okay, so let's set up the integral that would allow us to do that. What would I integrate? What would the equation be that I'm putting inside my integral? 2x squared minus 3x plus 2 dx, very good. And on the bottom, I would have 0, and on the top, I would have 2. All right, are you all comfortable integrating that, and then you plug in the 2 minus plug in the 0? Okay, to save time, I think I'm going to. It's always, what it represents is the area that's that's bounded by the graph and the x-axis. So it's always, yeah, yes, it's always the x-axis. So in just a minute, part of our graph is going to be below the x-axis, and we're going to see what happens to there. Consider the graph of f of x equals x squared minus 6x plus 8. Use the graph screen on your calculator to answer the following questions. Find the total area that's enclosed by the graph of f and the x-axis on the interval between 0 and 5. All right, so first off, we probably need to graph this. Is it minus 6x plus 8? I'm going to try zoom 6. Just see how that looks. Okay. And the question is asking me to find the total area that's enclosed by the graph of f and the x-axis on the interval from 0 to 5. I'm going to go back here and draw it on my paper so I can kind of get a better idea. Where does this graph cross the x-axis? 2 and 4, right. And you can see that pretty easily on your graph. You could have asked the calculator to actually calculate that, or you could have set it equal to 0 and solved for x. But basically, your graph is looking something like that. Tomorrow you made me nervous. So the directions say to find the total area that's enclosed by this graph and the x-axis between 0 and 5. So that means that I've got this little segment right here, that little segment, and then this little segment right here. But I'm looking for the area that's enclosed by the graph and the x-axis. So it's okay that it's below the x-axis. But I'm going to show you what happens to the integral when the graph is below the x-axis. So what I can do, and it says to do this on the graph screen. If you go back to your calculator, and on the graph screen, if you go